we now move on to cumulative probabilities. A cumulative probability is simply a probability that consists of several different values. So something like the probability x is less or equal than r, or the probability x is greater or equal than 6, or the probability that x is between 1 and 5. Cumulative, from cumulative distributions, is just all of the values up to and including a certain point. Before we get into finding any probabilities, the first thing is to understand how to use the BCD function on your calculator. This stands for Binomial Cumulative Distribution. So firstly, watch one of the videos on that, and then you'll be ready to understand how to use it for the following examples. So let's just take a very simple example first. Suppose x follows a binomial distribution with 25 trials and probability of success 0.2, and let's find the following. Let's firstly find the probability x is less than or equal to 5, b, the probability that x is greater than, let's say x is less than 10, and part C, the probability x is at least 8. And so there are a number of different ways you can do this. One way is to use your calculator. So for the first one, the lower and upper, so obviously n is 25, p is 0.2. The lower limit is 0, because when you're doing the binomial distribution is discrete, it can only take whole number values between 0 and n, and the upper value is 5. Alternatively, you can use the tables. So on page 204 of the textbook, there are tables of cumulative values, and those are also given in the formula book. So if we go to page 206, we've got n is 25. If you find p equals 0.2 at the top, and then if you go down to 5, we get the value, which is 0.6167, and that's the answer. So the values given in the table are the values for probability x is less or equal than r. Okay, so that's the answer to part A. But obviously it's often quicker to use your calculator, especially if the thing you have to find, like in part B and C, isn't of the form probability x is less or equal than r. So B is to find probability x is less than 10. Well, firstly, note that if x is less than 10, x can't be a decimal, x can only be a whole number. So this is the same as the probability x is less or equal than 9, because we couldn't have, for example, x equals 9.3. And then you can do the same thing, lower 0, upper 9, or use the table in the book, and we get 0.9827. Part C, probability x is greater or equal than 8. So again, if you want to use your calculator, you can use a lower value of 8 and an upper value of 25, or anything bigger, because of course, if it's bigger than, it can't be bigger than 25, but the probability x is greater than 25 is 0, so it won't matter. Or use the table, but here you have to be careful if you want to use the table, because this is the same as one. We need to convert it in terms of something that involves a less than or equal to, because all of the probabilities in the table are like that. So this is 1 minus the probability x is less or equal than 7, which is 1 minus, and then if we go to the table, that's 0.8909, which is 0.1091. And that's the answer. So often it's quite easy to do on your calculator, but sometimes you need to be careful if you want to use the table. And the other thing to be careful of is wording in questions. So sometimes the way the question is worded, you first have to think about what it actually means. So there's a nice summary in the book presented in a table. So if you see the phrase greater than, for example, 4, this means you need to find probability x is greater than 4, which is the probability x is greater or equal than 5, or 1 minus probability x is lesser or equal than 4. So you have to be careful here. When you see greater than 4, that doesn't include 4. Similarly, if you see fewer than 10, this means probability x is less than 10, which is the same as the probability x is lesser or equal than 9. If you see the phrase at least 6, that means the probability x is greater or equal than 6, which is also the same as the probability 1 minus the probability x is less or equal than 5. You see the phrase at most 8. This means probability x is less or equal than 8. And if you see the phrase no more than 2, this means the probability x is less or equal than 2. So it means the same as at most. So this wording and the subtleties here are very important, because if you get the wrong thing, you'll get the wrong answer. So just think carefully about whether or not the word includes the value. So whether the inequality is strict or not. Okay, and now we move on to a realistic type of question you can get in the exam. So you're not likely to get a question like this, what we did here. This is kind of too straightforward. You're more likely to get a question that involves some context. So in this question, we have a spinner lands on red with probability 0.3. Jane has 12 spins. Find the probability that A, Jane obtains no more than 2 reds, and B, at least 5 reds. And then we're told Jane uses the spinner for a competition. She wants the probability of winning a prize to be less than 0.05. Each person will have 12 spins, and the number of reds will be recorded. And then part C is find how many reds are needed to win a prize. Okay, so this part C looks quite difficult, and it's a slightly different type of question. But A and B should hopefully be fairly straightforward. So let's first think. We have the spinner. P is clearly 0.3, and N is 12. There are 12 trials. So if we let X be the number of reds, then X follows a binomial distribution with N is 12 and P is 0.3. So the probability of no more than 2 reds, well, no more than 2 is the same as at most 2. So we can just either, again, use the table or use your calculator to directly calculate the probability that X is less or equal than 2. So in this case, we're going to get 0.2528. That was A. And then B, at least 5 reds. That's the probability X is at least 5, which, again, either use your calculator directly, or if you need to use the table, first convert it to 1 minus the probability X is less or equal than 4. And then looking up in the table, we get 1 minus 0.7237, which is 0.2763. Or your calculator gives you that directly. Part C. Well, we need the probability of a prize to be less than 0.05. We need to find how many reds. So why don't we this time let R be the number of reds needed to win a prize. We want the probability X is at least R, because R is the smallest number. So yeah, if we let R be the smallest number of reds needed to win a prize, we want this probability, which is the probability of winning a prize, to be less than 0.05. Each person will have 12 spins. The number of reds will be recorded. Okay, so this type of question is slightly more complicated. And again, there are a few different ways to do it. One way is to use the table again. Your calculator can actually make the table. The table is in the formula book, but this type of question I probably recommend you either do that or use the tables that are given in the formula book. So we go to n is 12, p is 0.3. Notice that, well, let's convert it to something in terms of probability X is less than or equal to something. So the probability X is greater or equal than R is the same as 1 minus the probability X is less or equal than R minus 1. Because if you think about something like probability X is greater or equal than 5, that's the same as 1 minus probability X is less or equal than 4. And this rearranges, if we move this term to the other side, to the probability X is less or equal than R minus 1 is more than 0.95. So if we go to the particular column in the table, and we're looking for the first value that's more than 0.95. And we can see that's going to be 6. Because we can see from the table, the first one, we have probability X is less or equal than 6, is 0.9614. The other side, if you use 5, you get 0.8822, which isn't big enough. So if we kind of match up what we've got, we need to have R minus 1 equals 6. So R is 7. So the smallest number of reds to win a prize is 7. And we could also ask what the probability of winning a prize then is. Well, the probability of winning a prize, which isn't asked for in the question, but we'll just do it anyway. Probability of winning is the probability we get at least 7, which is 1 minus 0.9614, which is 0.0386. So there's 3.86% chance of winning a prize, which is less than 5% as we require. So this type of question where you have to find this value of R is a bit more demanding, and one way of doing it is this method using the table, which I think makes it quite easy to see whether you have the right value or not. And you can always check. You can, so we checked here our answer was sensible, but also you can check the values either side of 7 if you're not certain you have the right value here. So understanding this method will also be important in the next chapter on hypothesis testing, because quite often we have to do this kind of procedure when we do a hypothesis test.